In the early attempts made by the two scientists, Dobrynin and Newland. Now, after that came Russian scientist Mendeleev. Mendeleev was the first scientist who studied the properties of all the elements and their compounds in detail, and then he prepared the periodic table. And that's why this periodic table is very close to modern periodic table. But only difference is, again, Mendeleev prepared the periodic table on the mass, atomic mass. So again, he arranged the elements in order of the increasing atomic mass, and he found that the properties of the elements are the periodic function of their atomic mass. So this is most important. This is called the Mendeleev's law of periodic function. So we know what is periodic. Periodic means when certain incident takes place in equal interval of time again and again. As we know, the day is a periodic, year is a periodic, month is not periodic because month sometimes 30 days, 28 days, 31 days. So months are not periodic. We know, but weeks are periodic. Because after Sunday again comes Monday, Tuesday, again Sunday. So it is called periodic. So same we'll find the periodic means yes, certain incident takes place in particular interval of time. So again he classified the elements, and on page 18 he has given the how he classified the elements. During his time 63 elements were there, and all elements he classified. So here some merits are there and some demerits are there, and these are very important. The merits and demerits of periodic function or means Mendeleev periodic table. So what were the merits of it? If you look at the periodic table, you find that he corrected the atomic masses of the some of the elements. When, for example, beryllium, earlier the beryllium had been given the mass 14.9, but according to the property when he placed, then he found that beryllium has a mass 9.4. So first he corrected the atomic mass of some of the elements. Then during his time all the elements were not discovered. Some elements were undiscovered. They are not known. You will find that aluminium, below aluminium, silicon and boron, there the blank spaces are there. Blank spaces. Because elements were not discovered. But even though he predicted their properties. Why? Because they fall in same category. Suppose aluminium is there and below aluminium any element is not discovered, but the property will be same. And that's why these elements which were not discovered, he gave the name Eka boron, Eka aluminium and Eka silicon. And after the discovery, they found that they were scandium, gallium and germanium, and they were the properties of the same. The scandium had the property of boron, gallium had a property of aluminium, and germanium had a property of silicon. So all these undiscovered elements which he predicted the properties were found to be correct after the discovery. This is the second merit we can say, or second advantage of this periodic table. One more there, the noble gases were not known that time, noble gases. But when the noble gases or the inner gases we call them, these were discovered, then they were easily placed in the eighth group without disturbing the table. Without any disturbance to the table, they were placed in that. And therefore, these are, we can say, the merits of the Mendeleev periodic table. However, there are some demerits of his periodic table. What are the demerits? Because Mendeleev had arranged the elements according to the atomic mass. Now you find that atomic mass of nickel is less than the of cobalt. Cobalt has the atomic mass 58.9 and nickel 58.6. Even then, according to property when they placed, then cobalt was placed first before nickel. Actually it was wrong because it was according to the atomic mass. So, according to atomic mass, nickel should come first and the cobalt should go back, means second place. But according to property he had kept this, and that's why you find one anomaly. Second anomaly, you find that isotopes later discovered did not find the place in Mendeleev periodic table. Why? Because isotopes we know. For example, if you take carbon, carbon had two isotopes, carbon 12 and carbon 14. Now carbon has atomic number 6, but isotopes same atomic number but different atomic mass. And therefore, since that different atomic mass, then it will come with nitrogen, because nitrogen has mass 14, and therefore carbon will come with nitrogen. So isotope of carbon 14 did not find the place in this, and that is the second demerit of Mendeleev's periodic table. Now third demerit, we find that some of the elements having similar properties were placed in different groups, and different properties were placed in same group. Here the some examples you'll find here. Some examples given on page 20, that some of the elements were similar properties were placed in different groups, and different properties in place group, say in the same group. And one more, the last one, hydrogen. Actually, hydrogen can react with both. Hydrogen can react with sodium alkaline group and the halogens group, but he has been placed in the first group, and that's why you'll find that hydrogen did not find the proper place in Mendeleev periodic table. So these are the drawbacks of Mendeleev periodic table. Very important. Merits and demerits are very important, and this question can be asked in exam. Achha, just now we have studied Mendeleev's periodic table, and in that periodic table we are saying the Mendeleev some merits and demerits. Achha, Mendeleev arranged the elements in rows and columns, and you find that horizontal rows are called periods, and in Mendeleev table you find the 7 periods were there, and vertical columns are called groups, and 8 columns were there, or 8 groups were there. Now, until the end of 19th century, we'll find that the early atoms were made. That time the atom was not fully understood, and that's why they took the mass as a characteristic property of the elements. But at the beginning of the 20th century, when atom was fully understood and atom was divisible, then they found that in atom the protons and electrons are there, and protons and electrons, which are called the number of atomic number, and therefore you find that when modern periodic table was prepared, the modern periodic table was prepared on atomic number and not atomic mass. So Mendeleev's periodic law and modern periodic law, only one difference is there, and that is the difference of the word, that instead of mass just write atomic number, finished. So not mass but atomic number, and that's why the modern periodic table, the law of modern periodic table is the properties of elements are periodic function of the atomic number, and atomic number means number of protons. So here write atomic number and not atomic mass. So we can see that it is a mistake, but it is not a mistake but human error, because till then atom was not fully understood. But in the beginning of the 20th century, when atom was understood, then they came to know that it is not atomic mass but atomic number, and you find the modern periodic table is based on atomic number. And if you see the modern periodic table, so there are rows and columns on page 23. You see the page 23, there are rows and columns are there. There are 7 rows are there, and these 7 rows are called periods. So there are 7 periods, and 18 columns are there. You can see 18 columns, 1 to 18. The first column with hydrogen, lithium, sodium, potassium, and the last you'll find that inert gases. So 18 columns are there, and these columns are called groups. So we are going to study the modern periodic table in detail. Let us study the modern periodic table. The table is given on page 23. So please open your book at page 23, and you find that they are given 103 elements. Actually 180 elements are there total, but 92 elements are found in nature, and the remaining elements are man-made, and they are found in laboratory or during the radioactivity. So that we'll see afterwards. So you find that this table is based on atomic mass, not atomic mass, but atomic number. You find there are columns are there and the groups are there. The columns are called the groups, and the first group you find, first group, hydrogen, lithium, sodium, potassium, rubium, cesium and francium. This first group called alkali metals. Keep in mind the first group called alkali metals. The second group beside the first group, second group is there, barium, beryllium, magnesium, calcium, strontium, barium and iridium. This is called alkali earth metals. So alkali metals and alkaline earth metals. Then find that 17 group, 17, also called 7th A group. 7th A. They are called halogens. And which are the halogens? Chlorine, bromine, bromine and iodine. They are called halogens because they form the salts. When they combine with metals, they form salt. We know that. For example, sodium is a metal, and when chlorine combines with sodium, it forms sodium chloride. We know that sodium chloride is a salt that we use. And in them say the different types of salts are prepared when they combine with the metals. For example, if you take potassium chloride, potassium bromide, potassium iodide, sodium iodide. We know sodium iodide is a very important salt, for body. So all these salts are prepared by these non-metals, chlorine, bromine and iodine, which they combine with metals, and that's why they are called halogens. And you find the last group called inert gases. In that inert gases you find the last one in 18 group, helium, neon, argon, krypton, xenon and radon. Don't take this 118th one. They don't have existence. So helium, neon, argon, krypton, xenon and radon, they are called the inert gases, or also called noble gases. Why? Because they do not prepare, or they do not form any compound, because they have no reactivity. They are inert. They do not form any compound with any other elements, and that's why they are called inert gases. Stop it for Achha, if you observe this table, periodic table, you'll find that there are groups and the periods. You'll find the first period, very first period, the two elements are there. You'll see the first period, two elements. First period, hydrogen and helium, two elements, because they have one shell, number of shells. So one shell, two elements. Then you find that second and third, both have each 8 elements. You find second group, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And third, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So each one, second and third group, each one has 8 elements. Then you find that fourth and fifth, they have 18 elements. You will see 18 elements. Again, the transition elements have come here. 18 elements. And 6 and 7, they have 32 elements. Now see this number. Have you studied this number, or have you seen this number somewhere? Yes. You find that this number is related to 2n square. We know the number of electrons in the outermost orbit, or the number of electrons. Then we know the first orbit. If you take n equal to 1, the 1 square is 1, and 1 to the 2. Then if you take n equal to 2, then 2 square is 4, and 4 to the 8. If you take n equal to 3, then 3 square is 9, and 9 double 18. And if you take n equal to 4, then 4 square is 16, and 16 to the 32. So you find that first group only 2, and therefore it is called short period, or we can say shortest period. Is the shortest period because only 2 elements are there. First period, 2 elements. Second and third is a short period because only 8 elements are there. Second and third. Fourth and fifth long, and 6 and 7 longest. You can see longest. At the same time, you'll find they are divided into 4 blocks, S, P, D and F. You can see the 4 blocks are there, S, P, D, F. The first block, 2 elements are there, 2 are there. S 2 are there, that means 2 groups are there. P, 6 groups are there. D, 10 are there. And F, 14 are there. Now see, what are these? I told you just now that we are going in the school of elements, because in first orbit, there are 2 electrons we can know. Then in the first standard, only 2 students are there. First standard. But second standard, so first standard, two students are there. That's why they are kept in only one class. But second standard, 8 are there, and 8 are there. Therefore, there are 2 classes. The first 2 students and second 6 students. In third standard, 3 classes are there. 2, 6 and 10. Third standard. Fourth, 4 classes are there. As the number of standard increases, the number of classes increases, the number of standard increases, the class also increases. First standard, only 1 class is there. Second standard, 2 classes are there. Third standard, 3 classes are there. Fourth standard, 4 classes are there. 4 classes are there. But first class is 2 number, second class 6, third class 10, and the fourth class 14. This is order. And that's why you find that first group, first period, 2 elements are there. Second, 2 and 6 you find. So this is called S block. This is called P block. This is called D block, and that's called F block. So S, P, D, F. So S block, only 2 elements are there. You can see that 2 are there, 2 groups are there, S block. P block, 6 are there. You can see in the table that 6 elements are there in P block. In each period, 6 are there. In D, find the 10 are there. 10 elements are there in D. And F will find below. It is below given that F, 14 are there. Now, how these have come? So, if you write it this way, S, SP, SPD, SPDF, if you write it this way, then first you'll find S, 2 will be there. Then after S, here P comes, S and P. So S, SP. Now here S and P will come here. So you'll find the third group, S, P and D also comes here. See, D also comes in third group, S, P, D. And in this way, they have been formed. So here, D group is called the transition elements, transition. So first and second, S block and P block. Earlier they were prepared, but later on they found the D block also is there, and the D block is kept between S and P block. And since they are placed between these two, they are called transition elements. They are all metals are there. They have nearly similar properties. So we have seen the modern periodic table has been divided into 4 blocks, S, P, D, F. We will find that S and P blocks, they are called normal elements, because they have only one shell incompletely. The last shell is incomplete. Before that, inert gases, though they lie in P block, all shells are filled. And since all shells are filled, they do not either give electron or take electron, and therefore they are inactive. They do not take part in any chemical reaction. That's why they are called inert gases. Then transition elements, we will find that transition elements lie between S group and P group. Between S and P, the D block lies. They are called transition elements because they have 2 shells incompletely filled. All the transition elements, the outermost 2 shells are incompletely filled, and that's why they are called transition elements, and they are all metals. Take note of this, that all metals are there. In S also metals, but P group This P group consists of metals, non-metals and metalloids. Both are there, all three are there. So S only metals, P metals, metalloids and non-metals. D also all metals and F all metals. So D two last shells are incomplete filled and therefore they are all metals are there. Their compounds are colored and most of the transition elements are, you can say that they help, that is for catalyst. So they help in catalyst in the reaction. And in inner transition elements, these are reactive elements and they have last three shells incompletely filled. Now next we will see the valency of the elements. You will find that those in large in first group, they have one valency. Those in lie in first group, they have one valency. Those in lie in second group, they have two valency. The third group, you will find here, third group, they have three valency. Valency is 3, valency 4, valency 5. But you find that 5 electrons in the outermost orbit. So they need 3 electrons, and that's why valency decreases again. You find then nitrogen 3 valency, carbon has 4 valency, nitrogen 3 valency, oxygen 2 valency, and fluorine, chlorine, bromine, all these have 1 valency. They do not have valency because the outermost shell is completely filled. So you'll find that group number is the number of electrons in the outermost orbit, is a group number, and therefore you'll find that every group, every row begins with 1 electron in the outermost orbit and ends with complete octet. So group number, we can say that number of electrons in the outermost orbit. So we have seen that valency increases from left to right. So it increases from left to right and again decreases because it becomes negative. Now next we will see the atomic size. So atomic size, if we take a particular row, that atomic size decreases from left to right. Atomic size decreases from left to right. Achha, why does atomic size decrease from left to right? You'll find that if you take the particular group, means particular period, then in period the number of shells remain constant. So if you take the second period, we'll find in second period all the elements have two shells. The first shell 2 electrons, and the next second shell you'll find that the number of electrons increases. The first group 1 electron, second group 2 electrons, third group 3 electrons, and so on. And as the group number increases, the number of electron increases. As the number of electron increases, number of protons increase, and both increase. And that's why number of protons and number of electrons increases. So you'll find the attraction increases because there are more protons. And number of protons and number of electrons, as they increase, the attraction increases, and as attraction increases, the radius decreases, and as the radius decreases, the size decreases, and therefore you find that from left to right, the size of an atom decreases. But as you go from top to bottom in a particular group, top to bottom, you will find the number of shells increases. Number of shells. The first period, 1 shell. Second period, 2 shells. Third period, 3 shells. Fourth period, 4 shells. As the number of shells increases, the size increases. And that's why if you take a particular group and if you come down from top to bottom, then you find the size increases because the number of shells increases. So once again, from top to bottom in a particular group, the size increases. But if you take a particular period and if you go from left to right, then the size decreases, and size decreases because of the more attraction. As the size decreases, because the number of protons and number of electrons, they increases, and therefore because of the attractive force between them, the electrons come closer, and as they come closer, the size decreases. And this question is very important, can be asked, give reason in the exam. So this is about the size. Now next we will see the metallic property. Metallic property, find the metallic property of the element as you go from left to right. The metallic property decreases because metallic property depends on the the tendency of losing electron, and as we find that in the first group one electron is there, and that's why one electron, so this is a big size, and big size is there, the distance is more. As the distance is more, the attractive force is less, and therefore that's why the electron can be easily lost. And since it can lose the electron easily, and that's why it is a strong metal, so you find that if you take a particular group, suppose the third period, if you take third period, sodium, magnesium, aluminum, silicon, third period, you'll find that sodium is the strongest metal, stronger than magnesium. So magnesium is stronger than aluminum, and then silicon. So you find that sodium, magnesium, and aluminum are metals, whereas silicon is neither metal nor non-metal. It is called metalloid. And again find the non-metals we start. So left side strong metals, and right side extreme light non-metals and inert gases will find. So metallic property decreases as you go from left to right. Also we can see one more here, that potassium, calcium. So potassium is stronger than calcium. Calcium is stronger than gallium and germanium. Acha, one more thing you'll find in this, that between metals at the left and right, non-metal at the right, you'll find there is zigzag line is there, zigzag line. So this zigzag line is of metalloids. These are metalloids. Then they have both the properties of metals and non-metals, and you find that surrounding this zigzag line, both the sides of zigzag line, you find that metalloids are there. For example, boron, B is there, B in fifth, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are all metalloids. So keep in mind once again, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are all non-metals. Keep in mind, they are non-metals. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, non-metals. So left side of non-metals are metals are there, and right side of metalloids, left side of metalloids, metals are there, and right side of metalloids, non-metals are there, and then last one, gases are there. First